Hi, my name is Corey Derringer.
And I'm Claire Williams.
And this demonstration is called the Best Blade Challenge. So Claire, would you like to play the Best Blade Challenge?
Sure.
What we have here is we have three blade designs, and each of them is hooked up to a little miniature turbine and wired to a multimeter. The multimeter measures the output in volts. So what we do is we have our wind source here. It's not a hairdryer. And we're going to turn the wind source on high and point it at each of the blades about an inch away, and we'll find out which one puts out the most volts. Since we're scientists, we have to have a hypothesis first. So which one of these do you think will do the best?
I'm guessing this middle one because it's what I usually see in the fields.
Yeah, it's a really reasonable guess. Go ahead and get the wind source right up close. Test it. Awesome. All right, so what's our readout looking like now?
It looks like 0.80.
0.80, okay. All right, so a little bit less than 1 volt. Now try this one.
Oh, wow.
Oh, quite a bit better, yeah. Maybe a good guess, yeah. What was your readout?
That looks like 4.25.
4.25, all right. Now try this one.
Wow.
Ooh.
That looks like 5.5.
5.5, okay. So which blade scored the best?
This one.
All right. Why do you think it was the best?
My guess is that there's 4 blades, but I'm not quite sure.
Yeah, well, I mean, it has more blades. Also, the blades are wider. There's more surface area, so it catches more wind that way. If you look at this one, you have these long, skinny blades, and this one's got the fatter blades. Also, I don't know if you can see this very well on the camera, but this blade doesn't have very much of a pocket here. It's actually pretty poorly designed. The wind just is going to kind of slide off. And this one has a little bit better, but this one has nice pockets. It catches the air. It's like a catcher's mitt almost. So I mean, if you've ever driven down the highway and with your hand out the window, if you cup your hand like that and you can go up and down through that, but if you flatten it out, you catch less wind. It's the same concept, except you're catching wind in the form of a turbine, turning it into electricity.
So let's break it down. There are 3 steps to the Best Blade Challenge.
It's set up a lot like a scientific experiment. First, we have the participant guess which blade is going to be the best, kind of like a hypothesis. Second, we actually collect data. And third, we analyze the data and discuss why this blade is the best. There are several factors which make one of these blades better than the others.
First is the number of blades. Second is the surface area. And third is the pitch. A common question we get with this activity is why do we tend to see the 3 blade design over the 4 in the fields?
There are a couple of really good reasons for this. The first is that you have much less materials with a 3-blade design. So it's going to be cheaper to produce. It's also going to be less weight, which is going to mean less wear and tear. Another big reason is that if you remember from the other video with the Beaufort scale, we actually, the turbine spinning too fast is actually a bad thing. There is an optimal Goldilocks zone, if you will. And this blade design is much better for that than something like this would be. This works really well in the lab, but this works very well for the kinds of winds that we see in the field. So Claire, as an educator, what do you like best about the Best Blade Challenge?
Well, I like the participation that we can get from the students. They actually get to play with the wind turbines and blades, and it actually gets them thinking about the different types of blades.
Yeah, that's really cool. Personally, what I really like about it is that it gets kids thinking, or gets, I guess, anyone thinking scientifically. It's not just that we take a guess which one is intuitively the best. We actually get to collect data, actually analyze it, have a discussion.